All right, welcome everybody. I'm so happy to talk to you today about science communication and AI education. My name is Andy Forest and I'm the executive director at Steamlabs. And Steamlabs is a small nonprofit in Canada, and we've been doing tech education for about 11 years now. And we have a focus in the past 2 or 3 years on AI, because we look for the kind of gaps and the areas of technology that are kind of leaving people behind and that are the most important in the impact that they have on people. So we've been focusing on AI education. But today I wanted to start by talking about science communication in general and talk about why it's important to communicate the scientific concepts to the general public, and why it's important that you as researchers, engineers, and scientists are able to communicate your work directly to the public to hear your voice. So I'll start with a presentation here. Everyone see my screen okay? See, no, it's excellent. Okay. So there's my Twitter handle. If you want to talk with me about on Twitter, I'll share my email address later too, so we can have any follow-up conversations that you want later. So this presentation is actually lent to me by Dr. Marianne Mader, who's the executive director at the Canadian Association of Science Centers, and she's presented this a few times. And I've kind of a special in with her since she's also my wife, and so she gave me permission to use these slides to talk about this topic with you, and then also gave me permission to share the presentation with you afterwards as well. So if you want to, and there's some slides that I won't be going into, so there's some more details, so that way you can look at it yourself later too. So, and there's her Twitter handle too. She's amazing at science communication and these types of things. I would recommend following her on Twitter, even more than me. So the first thing I want to talk about is relevance. So the previous slide said, is your science relevant? And so sometimes we think that everything that we're studying, of course, is relevant. It affects so many people. It's really impactful to such a large group of people. Of course, it's relevant. But we have this kind of idea that everything we know how important it is, so then it must be important to everybody else. So here's just an example of GPS. So GPS is in everybody's pocket in their cell phone now. And there's the theory of relativity that is making GPS possible. So of course, this kind of fundamental science is incredibly important to everybody, but it doesn't quite work that way. It's all encompassing on the whole Earth, and it affects everybody. But relevance is really relative to the actual individual impact that people think that it has on them. So, because people are busy, our work is only relevant to people when they think it's relative, not when we tell them that it's relative. So there's this book by Nina Simon that has a bunch of these concepts in here. This book really changed the way that I think about our work. So I really recommend that you read this book, and it's another great person to follow, because she talks about how likely that new information will yield new conclusions that matter to you. That's what makes something relevant. But then there's also kind of added lens, which is how much effort that they're going to have to go into to absorb that, and to actually absorb that into their life is also a big part of that. So yeah, and the lower that effort, the easier that you make it as a science communicator, then the higher that's going to make the relevance to them. So I've got an example here just around climate change. So you think climate change is another thing that affects everybody. You think it's going to be relevant to everybody, but there's a lot of research showing that it's a struggle sometimes to make it directly relevant to people in their lives. So here's one possible approach. You see there is there's my lifespan. Somebody and you can see that the climate change graph here of the surface warming temperature doesn't really impact me so much in my life. It does, but we're not getting to that level where it's +2 degrees. We're not really getting super far past that in my lifespan. So if we talk to me about my kids and my grandkids, then that can make it more relevant to me, because I care about them. and I care about the impact that that's going to have on them. Here's another way to bridge that. Here's making it locally relevant. So here's how much climate change is going to cost in all kinds of different areas all across the United States. So you can see how you can make that locally relevant to people. However, this is really dense. This is maybe not the best way to present this information to the general public. This is not easy for everyone to digest. So here's another approach. Here's an actual scenario in Miami, and this is a depicting sea level rise and the kind of the impact that's going to have. So here, if you live here in this condo, you can directly see, yep, I'm going to have to care about climate change, and that's going to make it much more relevant. So, and then you can think of ways to share that with people. Is that in shared online or at the condo meeting of this condo right here, so that we make that directly relevant. So that's just some examples about relevancy. So then the next section we'll talk about actually the science behind science communication. And this is, we're going to talk about it in this kind of quick, we're hopefully finish up this part in about 20 minutes, where we've got these 5 what, who, where, how, why, similar to journalism, of how you're going to communicate these ideas. So you might start off with this kind of idea and this kind of impression of the what are we going to inform people about? And so this is just, are we going to just take some facts and some science and pour them into people's heads and then they'll understand and absorb it into their lives? No, we need to do a bit more work than that. And one of the reasons for that is that the things that the public talk about and are interested in are different than the things that the scientists talk about or are interested in. It's really a oranges to apples kind of situation. And and research has shown that when scientists just sort of talk facts at the public, it doesn't work. People don't absorb it in that way. And there's a number of different reasons for this. But here's an infographic from Dr. Chantal Barillon, who's the director of the Science Communication grad program at Laurentian University, an amazing program. I've worked with some graduates from there. And in her research, she's found that people use these kind of mental shortcuts to quickly evaluate these facts that you throw out there at them. And these are kind of 3 of the mental shortcuts that can cause them to discard those facts and not absorb them into their worldview. So the first one is, does it fit with what I know and believe already? And if it doesn't, that they can just use that mental shortcut to just like, nope, eject. They don't even try to absorb it. The next one is, people are very willing to protect their personal interests, beliefs, and values from any kind of conflicting information. So they put up a lot of armor against things that conflict their worldview. And they're not, doesn't mean that they're impervious to these conflicting thoughts. It's just they're going to protect them. They're going to have a higher barrier to absorbing that knowledge. And then the third one is that sometimes they'll just rely on a trusted source to evaluate that information. And if that source that they trust is telling them something different, then that's another mental shortcut they can make and just say, well, they said it doesn't matter, or this isn't interesting, so it's not to me. So those are some of the shortcuts that we have to get past to communicate effectively. So let's talk a bit about that armor and that disentangling of their identity from the knowledge. So here's some research on how people answer this question. So there's just true or false question. They asked, human beings, as we know them today, developed from earlier species of animals. True or false? And then they graph this against their general science intelligence, just a measure of just their kind of knowledge of science in general. And as you would expect, the more kind of general science knowledge that they had, then the more likely they were to answer this question correctly. There's a nice positive correlation there. However, if you map that with their religiosity, so how religious they are, and then map that still against their general science knowledge, people who are above average religiosity, they actually went down in the correct answer of this question as they had more science knowledge. It went down. So, and that's because that question is tied into their identity, and they're going to protect that identity from conflicting knowledge. So how do we disentangle that? So there's some research here. There's some links in the notes I can send you that you can disentangle that by changing the question, and you can word it in a way that's not threatening to their identity. So you can word it in this way: according to the theory of evolution, instead, human beings, as we know them today, developed from earlier species of animals. And now you can see that question much more correlated with the correct answer. So that's one item in there. So the next thing is the who do we trust? So this is getting to that question about those shortcuts of a trusted person to evaluate these facts and these information. So there's some research done on this as well. So here's research done in Ontario by Ontario Science Centre that found that trusted sources for accurate fact-based information, science centers, scientists, and educational institutions were right up there with the top. Government, not so much, and other things. And I was really happy to see like bloggers and social and celebrities pretty low on there, because people, they pay attention to them, but they know they're maybe not a good source of fact-based information. So we're starting off here with some really great trust in the general public. But here's where people are actually getting their information. So yeah, the internet, magazines, newspapers, that's where they're actually getting them from. So so one of the things about that is meeting people where they are. So people are getting trusted information on the internet, books, magazines, newspapers. That's great. Meet them there, meet them online. But there's also, they can get more creative with where you meet them with the knowledge, and you can get creative with how that is connected to social media and online. So I've got an example from Dr. Marianne Mader. So she, before her role at the Canadian Association of Science Centers, she worked at the Royal Ontario Museum as a planetary geologist, and she saw an opportunity with The Martian movie. It was premiering at the Toronto International Film Festival in Toronto, also where the Royal Ontario Museum was. And so, and right in the ROM's collection, there was a chunk of Martian meteorite in the collection. So she arranged for Chris Hadfield to bring that of Mars to Matt Damon at the premiere. And this got tons of coverage online, and just a simple thing to just connect that science to the actual movie. You can see how happy they were about that. And it's pretty unlikely that these two would have posed for a promotional shot, but because it was connected to this awesome thing, then they did that. So there's some other examples in the presentation that I'll share with you, but there's other ways to just get out there and talk. Story Collider, personal stories about science is amazing. Samantha Yemen, Science Sam, she's another great person to follow on Twitter. She's a neuroscientist and also a science communicator. She's a PhD from U of T, but she just does all of these science communication outreach efforts and talks, and she's a really good person to follow. And there's other people you can look into here as well. Science Soapbox, Soapbox Science rather, another amazing organization that you can get some practice with if you want. They literally stand you up on a soapbox and you talk about science to the general public. It's a great way to just practice interacting with people and communicating. So that's some of the things about the where. Okay, so now moving on to the how and the why. So let's start with the how. And so there's a difference between how the scientific method, and researchers and engineers and academics are used to presenting their information. They start with the background, they build up to the methods that they're going to use to investigate something, and they present the results. So there's this whole process of establishing the credibility and the validity of what they're doing, and then communicating those results. Unfortunately, that doesn't work as well for the general public. General public wants to have the information first. They want to know the results. What is it that you're talking about? They want that first, and then you hook them, and then you can get into the relevancy, and then as you lead them down this communication path, you can eventually get to the background and the why, that they should believe what you're saying too. So that's kind of one starting point of kind of that inverted pyramid. Another really great tool to think about science communication is storytelling. So telling personal stories helps make science accessible to everybody. It connects to their life. You can also kind of use some of the principles of storytelling in your own presentations and educational opportunities. I'm going to be showing you a little later as kind of a case study, one of our AI education tools called Predict-a-Pie, and we have a whole story all woven throughout this activity to connect with people to make it relevant. So here's kind of a crib notes of 7 basic plots that you can use in your storytelling, with an example of a movie from each of those plot types, so that you can weave quick little stories out of these kinds of plot types. And here's this is one of the things that's a problem in industry is in the academic industry is just the importance of communicating is not, it's not universally shared. So there's the funding for doing basic research, for doing the kinds of research that is advancing our society frequently doesn't come along with requirements or even incentives to communicate that science to the public. So one thing that science communication professionals are working on is trying to get the communication part built into the research part, so that as you're going along and doing your research into your new AI models or the industry applications, alongside that is the communication of it to make it relevant and important to everybody. So that's the end of that presentation. Here's a quick summary of tweetable things that Marianne put together. So that's just a nice kind of wrap up of everything. That throwing facts at people doesn't work. Relevance is relevant. Know your audience, understand their values, and that people trust scientists. They trust you, but we need to meet them where they are so that we can make the knowledge that you have relevant to them. So that's the presentation on science communication. And then, so now I wanted to switch over to showing you this in action and with AI education. So hopefully it keeps sharing this. Can you still see my screen? It should say why AI. Yeah, awesome. Okay, great. Let me present this. Okay, so why AI? Why is AI a topic that I think that is very, very much in need of communication to the public? Obviously, all of you know why AI is important. You're all working in AI. You know this is an important topic, but I want to talk about why this is an important topic for everybody to know about and everybody to have some knowledge about. So there's the obvious reason that everyone knows that AI is producing automation. Automation is producing job loss. So that means that people have to adapt and then have new jobs and to replace those things that are not there anymore. But I want to turn that a little bit, to veer to the side a little bit and make a case for not just job replacement, but job change. So this is actually a graph on the percentage of the work activities inside of each of these industries that have the potential for automation. Not a percent chance that this job is going to be replaced. It's just the activities within that job actually have a potential for automation. So, and these are very wide ranging here. Accommodation and food services. There's manufacturing, which is really obvious, but there's a lot of the not so obvious ones here. Arts, entertainment, and recreation. Lots of potential for automation. So that's talking about the job activities within that job have a potential for automation. So in our AI education work, we try and have creative outputs, creative things that are being automated, not just things that are simple manual mechanical tasks and routine. They talk about in education circles, they talk about the difference between routine cognitive tasks and more complex cognitive tasks. And routine cognitive tasks that you might see in the manufacturing setting, obviously those are easy to automate. But these complex cognitive tasks, there are things that might be in like finance and insurance. You have to understand some complex things to automate tasks within there. So we're focusing on that area in our work, because we really believe that there's a future coming where everybody is going to have to work alongside AI. This isn't just about job loss. This is everything transforming. So because there's a growing body of research that's actually finding that AI is just one of a handful of human inventions that affects everything at the same time, all of the sectors. And this is known as like a general purpose technology, not a specific purpose technology that just accesses one thing. So it's really a core invention that's going to significantly affect productivity or quality across every sector and field. So, and there's I have some notes on some research behind that in the notes of this presentation, which I'll share later. So this is what makes AI literacy even more important than just coding skills, for example, because coding skills, everyone acknowledges, yeah, that's a really important skill. I think AI literacy is actually even more important because everyone's going to have to know how to work alongside AI. So what's standing in the way? Well, this doesn't help. This is some research from 2018, Deloitte, a survey of 1,000 Canadians, and yeah, people are not confident about what AI is and how it works. So what's the goal of our education activities to help with that? So we kind of have three kind of main points that we try and make with our AI education activities. We want people to be able to understand what kind of problems can be solved by AI, because not all problems are suitable for being solved by AI, both for technical reasons, but also for societal impact and ethical reasons. And then the next point is to understand how to frame those problems so that they can be solved by AI. So that's the computational thinking kind of part of it. How do you take that problem you have and then understand how to frame it for the AI? And a big part of that is the third point, which is understand what kind of data is needed, because the data obviously is a just core vital part to being able to produce these AI. And then woven among all three of those points is the ethical and social impact considerations. So we want people to be able to understand AI and use it as a tool. We also want them to be able to understand AI and demand responsible AI from companies, so that they can see practices that are not okay, and they can demand that those companies do better. Because the alternate society that we're going to have is one that we're just subject to all kinds of manipulation. Yuval Noah Harari has a series of books that I love. They're very forward-looking and interesting, and he poses this question of just like, what's going to happen to society, politics, and daily life when these non-conscious but highly intelligent algorithms know us better than we know ourselves? We have a future there that is not going to be equitable. We're going to be subject to a lot of manipulation in that case. And business actually understands and respects these points. So this is, again, from Deloitte. They have a series of reports called Canada's AI Imperative. And it's not just Canada specific, though. I'd recommend as more reading to everybody. But they make this point for social and ethical responsibility in that they're saying that Canada's businesses and governments, they have to work together to help Canadians understand AI so that we can develop controls, rules, and practices so that we can address those legitimate concerns about the impact of AI on our society. And and this is a business consulting agency that's saying, yep, we need regulation, we need good practices. And that's both from an altruistic, well, actually, I wouldn't even make the case that's altruistic. I'd make the case that it's good for business, for AI to be trustworthy. So they're making that case from a business angle as well. Okay, so that's the why AI as our focus part. Next, I want to show you this particular activity that we've come up with. So we do have a 2-hour-long training session on this activity. and the activity usually takes 1 hour to complete with the participants. So I'm going to be going through this much faster than usual, but to give you a taste. But I would invite you, if you do want to see this in more depth, that I would invite you to sign up for one of our education sessions. They are free for anyone serving a group of underserved youth that are low income and recent immigrants to Canada and some other demographic groups, for free if you're working with those groups. And then otherwise, it's a very affordable fee to come to our training session. You can go to steamlabs.ca to sign up for that. Yeah, this is, so I'll give you the quick version. So as I was saying, story time. We want to involve youth in these activities in a way that they can relate to. So this activity is aimed at high school students, but we can adapt it to younger or older groups. And we tell them that they're going to be a baker and they want to come up with some innovative new pie recipes. But you've got way too many ingredients to just randomly try them. So we're going to make an AI try them for you and come up with some ideas for some recipe combinations that might work. Okay, got a note alert that the meeting's going to end in 10 minutes. So when it does end, then I guess we will just rejoin again afterwards. Okay, so we're going to come up with an AI to try these different combinations. So how are we going to do that? We're going to use neural networks. You understand neural networks. You're working in this field. We talked a little bit about how all these individual nodes each make a small decision, and all of those small decisions can combine to make larger decisions. Then we base that on our inputs that we put into the system to base our predictions on, and then we have the outputs that come at the end. So we have a neural network simulator that we get everyone to experience this in. So show you that simulator. So here's the pre-trained network. So we've trained this on about 2,800 recipes, and we have all these different input ingredients that you can toggle on and off, and you can see how the neural network lights up and comes up with a prediction. And we deliberately made it a pretty small number of nodes so we would find some patterns in here. So I can put in here like a crust, sugar, and cherries, and it's 100% confident that that's a good sweet pie. So I can click yes on that. And then I can also, I can create a classroom here. And that makes me a link that I can create. I'll put it in the chat here if you want to try it out too. There you go. So you can click on that link and you can come to the same network that I'm looking at, and you can find some recipes for your restaurant. So we encourage the participants to choose what's the specialty of your restaurant. Is it pizza? Is it quiche? Or maybe it's a particular ingredient. Pick something that you want this network to be for, and then use that to find some recipes. And then you can click this Find Recipe Random button, and it just picks a random set of ingredients that is that endpoint that we wanted. So, and then we have some recipes that are kind of built into this that are contentious and that are for discussion. So the first kind of category of that is taste preferences. So we've got crust, pineapple, tomato, cheese, and ham pizza. Probably recognize that as Hawaiian pizza. Very contentious pizza. So many people love it, many people hate it. I like it, so I'm going to click yes. But we can see if anybody else is clicking on it in the classroom right now. We can look over here in classroom stats, and we can see how other people reacted to those recipes. And we can see the accuracy needle moving around. And if the group is old enough, and then we start talking about the math behind these things and about false positives and false negatives and how the accuracy percentage is calculated and all those things, and dive a little deeper. And then we can get into a discussion about why these particular recipes may not be suitable for people, because there's more than just the taste preferences. There's also things like religious differences. This has got ham in it. A lot of religions don't allow people to eat pork products, so it's not going to be suitable. There's allergies that may be a case. There's shrimp in this one. A lot of people have shellfish allergies. You can see where this model that's just trained for everybody maybe doesn't impact everybody. So then, at this point in the workshop, the next part isn't done yet. We're just in discussion right now with a chef that we're going to show this to, and then get them to react to it on camera and basically tell us on camera that this doesn't work for them because we haven't captured their style of cooking in here. We don't have the ingredients they use. We don't have the kinds of recipes that they make. So we'll in that pre-recorded segment, we'll come to the realization that we haven't built this to be equitable and inclusive. So we'll work with them on camera to say, okay, well, let's make a prototype of something that does work for you. Tell us about your cooking and why that doesn't work, and we'll use this neural network simulator here to build a new one. And then in this stage of the workshop, we just build it neuron by neuron to demystify the whole process. So I can put in, I'll just make a simple one here. So I can have cherries and then some sugar, and I can add a hidden layer in the middle here. So maybe this is a sweet filling. And I can connect those by dragging across. And this is going to be a sweet pie over here. Connect them all up. And now I'm going to need some crust there too. So let's have some flour, some shortening. And that's going to be the crust. I can connect those up. Go. And then I can have some other ingredients that are maybe not great. Maybe I've got onions because I've also maybe thinking about making a quiche. So then I can negatively activate that sweet filling there. And then I can just try it out. I can turn on these, sweet fillings activated, turn on these, I got crust, I got a sweet pie. But if I add onions to it, that deactivates the sweet filling. I don't have a sweet pie anymore. So there in just like 2 minutes, I built a fully functional neural network. And we can then add more to it to solve problems and add to their knowledge. So we can do things like, I want some options here. I want it to generalize. I want blueberries as a possible filling as well. So I can put that up here and put in here. Great. And now I'm going to turn off cherries and I'm going to turn on blueberries. Oh, that doesn't activate anymore. And then we can explain that's because by default, it expects all of these inputs to be activated. It has an equal weight on all of them. So then we can talk about, that's where the magic of machine learning happens, is that we can tell it with machine learning, we can feed it a recipe and say, here's a recipe for a pie that should activate this sweet pie. And then we can tell it, mess around with how important each of these little nodes are until you find a pattern that activates that. And you can manually do that by clicking here. And now I've got these weights here that I can turn up and down. So I can say that, well, sugar is more important than cherries or blueberries because it always has to be there. But cherries and blueberries are optional. I can have one or the other of those. So I'm going to leave those weights alone, and I'm going to turn this dial up to simulate the machine learning process of just like mess around with it until it activates. And you can see there's the threshold where it turns green. Great. And I can just leave it on there. Cool. Now I trained my network so that I can have a blueberry sweet filling or a cherry sweet filling, and they both activate that sweet pie. So that's the super simple version. And then what we do is we want to make this relevant to them, right? So we can make it relevant with this story of being a baker, but they're not actually bakers. So there's still a stretch there. So then what we do is we bring it back to an actual example that they do use in their life every day. And that is YouTube. So we have this example here, where here's actually 9 videos that YouTube recommended to me. How does that recommendation engine work? How does it know when I watch this video here in the middle, but how to make Trini macaroni pie, how does it know what to recommend to me next? And there's a neural network built in there. So in the longer workshop, we have the participants kind of guess, like, what are the inputs, right? Because those inputs are the things that it's going to base its prediction on. The output is going to be what video are we going to recommend, but what is the input for how it knows what video to recommend? We just start with that. And here's the AI computational thinking to kind of frame your problem in a way that the AI can solve. and we just brainstorm with them. And they quickly come up with lots of really good reasons. And in our workshops, we're actually amazed. We thought they would get a few, but they consistently get like almost the full list. Like here's from the YouTube recommendation research paper where they described the factors that are actually in the algorithm. And so, and they get these, they understand it. So what we do is we take the top one, the user's previously watched videos, and then we program this network together. Okay, so you can see here that we make a network that has the exact same inputs and the same outputs. So we line up all of the videos here that it's going to learn what video did you watch before, and then it's going to lead to some conclusion on the right-hand side about what video it should recommend next. And then we encourage the participants to think about how it could make that prediction. So you'll see by looking at these videos, there's actually some similarities to them. So this one says lion swims. So that's got an animal in it, that's got nature in it. Cooking by the river, that has nature in it too. So there's a commonality of that, of a category of nature. And there's other commonalities here across food and parenting and other things. And as the participants figure that out, we add them in. So we come up with this as our neural network. We've got all these categories in the middle, cooking, animals, nature, and parenting. And then we just connect up all of the inputs to those so that any one of those videos that will activate the corresponding category, and then the exact same mirrored structure on the other side. And then what we do is we adjust the weights so that we want those to 100% activate those categories on their own. And for those of you that can see, those of you with a background in machine learning, you'll know that this is actually a neural network architecture. This is a variational autoencoder. We've got the same inputs on one side and the other side, and we've got a bottleneck in the middle. We force the network to learn these patterns. So we can talk about how that you just built a real variational autoencoder. You're a machine learning researcher, amazing. And that sense of empowerment is really helpful to the participants to kind of open up this black box of what's inside there. How do these things work that we use every day? And this activity has come up in our surveys as consistently the one that people relate to and connect to the most. And then we try it out, and it just works. You can put that video in there as a starting point. It triggers cooking and parenting, and triggers all the other videos that have that combination of cooking and parenting. And then if there's time in the workshop, we go back. We say, okay, you did the first one. Now let's do the second one. The second one is high watch time. Which videos have a high watch time? So we add that in as another input. We connect that through to here, and then we connect that up either positively or negatively to all of these endpoints of whether they have a high watch time or they don't. And now you can see when you turn this on. So here's that one turned off. We get those, and when it's turned on, we get these instead, because these two videos had that as a higher watch time. And we can talk about then the societal impacts with the class of just like the design of these networks changes the way that we use them and interact with them. And we can have a discussion all about that. So that is that workshop. The next stage in the workshop, which I won't show you, is now we get the participants to design their own network. So we have a few different examples of the kinds of networks that they might want to do, just with a bunch of ideas and then questions to discuss afterwards. So we have some ones that are directly related to the examples, like detect combinations that work only in combination. So like an apple rhubarb pie, the rhubarb doesn't work by itself. Taking challenges like that. And then other kinds of totally different things. We've had participants come up with great things. One of my favorites is, one was a participant named Kai, and he made a network that was, will Kai find it funny? And then just kind of different inputs of types of jokes and situations, and then a prediction at the end of whether Kai personally will find it funny. Is that, how can you get any more personal than that? So that's the kind of output that we want to get with that. Great. So that is my presentation on that. So now it's the time is to talk and chat. So I'll stop the screen sharing and just now invite you to react to all of that and also to chat about it, to just how does this connect to your work and your goals. This doesn't have to be the end of the conversation in that regard. I'd love to talk to you more about what you're working on, and if there's a way that we can help you communicate it to the world. We're looking at modifying some of our tools. We have a bunch with 4 other workshops and tools that we could use to help you. So yeah, and I see, Tia, that you look eager to chime in as well. You want us to help this conversation along in any way?
Thank you so much, Andy. I think this may be the 3rd presentation I've had from you, and I learn every time, and I love it. I think I definitely want all of the fellows to please ask questions, but if you could, it always amazes me how you can take a machine learning concept and break it down for a kindergartner. And how do you get from this to this? Because I mean, you have been talking about that this whole time, but it's still, it's so incredible to me that I feel like it's, yes, you're simplifying, but it's not dumbing it down, so to speak. It's still treating them, like they have the intellectual capability to understand these concepts. So I think there's that real balance in not oversimplifying, but also in simplifying, if you know what I mean. So if you could speak to that.
Yeah, I think you're absolutely right. Yeah, that's one of our tenets. Like, we try and use real tools as much as possible. And with some of our earlier experiments with this workshop, we had it kind of abstracted more and less real, and that doesn't connect as well. And you're right, it's a respect for the audience too, to treat them that they can understand this and they can understand the full capability. So we definitely try and do real tools as much as we can. And we want to adapt this to one question we've gotten frequently in this, the predictive pi. People are like, how do I export my model? I built my model. How do I export it now and embed it in my website or something like that? Like, they want to use it. So that's showing that, like, it feels it's real because it's going to be a useful thing to them. So that's one feature that we're working on. Mo is here from my team too. So he's one of he's a machine learning engineer that's been working on a lot of our different activities. So yeah, if you have questions for Mo as well, then he's here too.
Hello, can you see me?
Yes, there you are. Nice background.
Thank you for such a great presentation. This is super interesting. I've been working with, well, we haven't worked with AI, but we're trying to see how to get younger kids learning STEM from a very early age, because we started working with university students, and when we were trying to get them engaged in entrepreneurship, we realized that a lot of their creativity has sort of been washed down through the years. We went lower down to like the high school level, and then we went lower down. We had like workshops with kids as young as 3 years old. It was absolutely amazing. And when you break down the concepts, like, young kids can actually understand and enjoy science, and they're not running away from it thinking that this is difficult and all of that kind of thing. So I'm really excited about taking AI to the lower levels. But my question is, what are your thoughts in terms of going even lower than the high school level? Maybe positives, negatives. What are your thoughts in that area?
Yes, such a good question. I agree with you entirely. Like, you going as young as possible, both for that creativity reason that you outlined, and but also for the kind of the foundational literacy. Like, literacy, this is a kind of literacy. It's a way of thinking, and the earlier that you learn a literacy, then the more it's kind of absorbed into your way of thinking. So I really applaud you for going as young as possible. I think there's some really good books. I love Lifelong Kindergarten, Mitch Resnick and the group at MIT, but have some really good tenets in there. That's one of my favorites for working with young kids, like just play-based learning and just exploring concepts by playing around with them. We've done some work with Teachable Machine with grade 1 to do some vision recognition activities. We have a workshop called AI for Zookeepers, where the kids set up a zoo situation and then they train an AI to recognize problem situations in the zoo. So, and in our test groups early on, they were all like, we want to detect that there's too much poo. And they would make just big piles of poo in the animal cage and then train the AI to recognize that and from different angles and stuff. And that's been really powerful to just get them to play with something. So yeah, another tenet I think that has worked well for us is that we have kind of a gradient with the really young kids. We try and get them to think about like how they can affect their own life in a positive way. Like just, you know, the really young kids will think about like, well, I can make a snack machine that can just deliver some snacks when we're doing robotics. And then as they get older, encourage them to like widen their circle of the people that they're thinking about to their family and then their community and then the world, so that they're kind of thinking about solutions for a wider and wider circle. But when they're really young, then it's about them and their life that they can think about when they're experimenting. So yeah, hopefully that's a few ideas.
I'm not a fellow, but I have a, oh, Tenzin, do you want to go ahead?
Oh, okay, sure. So hi, I'm Tenzin. I'm interested in data ethics, and I'm also like to write articles on Medium in my free time about AI. So I actually had a question about a point you made for a mechanism that people have when faced with new information is that they rely on trusted sources to evaluate new sources for them. So I was wondering, how does this amplify like misinformation on social media?
Yeah, that's a really good question. It does. Yeah. So yeah, especially when that source that they trust and is connected to their identity is amplifying the misinformation. So this is a whole area. So Dr. Marion Mader is now and CASC, they're leading an organization called Science Up First, which is specifically countering misinformation around COVID. So this is not a direct answer to your question, but maybe it's a way around it. Like what they're finding is that they're presenting facts. So that what they're doing is they're monitoring social media and they're looking for misinformation and they're looking for confusion. And then they have a team of scientists and medical professionals that then come up with the correct information around that same topic. And then they're empowering people to share that by making it like infographics that are tweetable, that can share on Instagram, so that then they're trying to get the people who are in the network of the people who are listening to untrustworthy sources. They're trying to get their friends to spot that their friend is listening to misinformation, and they're trying to get them to share it with them. So, for example, like if somebody's a brother is sharing misinformation based on a source that they trust, they're trying to get that person to then share back and say, oh, actually, that's not true about vaccine. Here's the actual information, and share back a trusted piece, because they are finding in research that helps, that another trusted source is kind of coming at it from a different angle with the other information. So I'll put a link in the chat to Science Up First, because they've got a bunch of information about that. There it is there.
Yeah, thank you. I find it interesting how you brought up that people rely on trusted sources, so like friends and family, because I remember reading an article from MIT Technology Review where they found that for my generation, like the younger generation, they're more likely to fall for misinformation if the person who's sharing the misinformation is someone that they kind of identify with. So
yeah.
I can go ahead. So yeah, I'm not a fellow, I'm the program coordinator for the area, but I just kind of had a quick question. I feel like your presentation and then the AI neural network that you showed kind of like intersects with like explainable AI and the importance of it. So like my understanding of explainable AI is that even if we can make it explainable, which is like really difficult when it gets more advanced, there's an issue of like the public just like not understanding AI, you know? So, I mean, like, what is your thought on that? And like, do you think that AI education is the answer? And if so, what are the limitations?
Yeah, really good question. Yeah, explainable AI is definitely intersecting with this. And in the explainable AI field, they talk about like the different stakeholders that need an explanation of how the AI works. And one of those stakeholders is the public, the people, or whoever the consumer of the model is. And of course, there's the engineers who are developing the model, there's the company itself, the engineers in the company, and then there's the regulators. So that in the work that I've seen, that's kind of the three groups. There's the engineers, there's the end customer, and there's the regulators. So I think that the end education definitely is impacting the end consumers of the models the most. But they're an important part of who needs it explained to them. So, and they need that AI literacy to be able to understand what's being told to them and explain to them about the model. And so, yeah, anything we can do in education to open up that black box helps. And then also helps for the push for explainable AI, because then the consumers can say to the company, hey, can you tell me how this works? And they won't accept an answer that's just like, well, we don't know. And then the consumer can say, well, we'll figure it out. There's work being done on explainable AI. Do connect with that and show me. So I really feel like it's a circle. It's like the education helps to people to understand it so that they'll use it, but also so they'll push for better education and better AI, and then that reinforces more AI use, and it's a self-perpetuating circle that education is just one part.
Hello, can you hear me? Yes. Amazing presentation. I really did enjoy it. The very beginning of your presentation, when you're talking about the relevancy of a specific topic, I like how you broke it down from like showing the map of the United States and seeing like where it's going to impact, like climate change will impact like more of the southern parts. But then you broke it down even further, and it was a specific part of Florida, and you could see where it's going to be flooded, and all of the buildings, what buildings are going to get affected, and all of that, right? Oh, and I just got a chat. My name's Martha Jesus. I'm a fellow here at AI for Good. So I was wondering, how do you go about presenting, I guess, new ideas, let's say in like finance or healthcare, where it's, you know, a little bit more I have trust issues with AI. How would you go and, I guess, explain, hey, I have this new AI that can do this a lot more effectively and efficiently for cost and human resources? How would you communicate that to someone in the position that could you what's it called, that could take that idea and make it a reality in their firm or whatever?
That's a really good question. And can I ask Mario, just I realized that Tenzin told me her area of study or research or productivity. I'm curious where your specialty is.
So I study computer science, and I have a focus on data science and artificial intelligence and software engineering.
Ah, fantastic. Okay, great. So then, yeah, maybe I'll answer from that point of view, because I think, yeah, I see. So you're specifically talking about like a company. So we maybe go to a company and say, hey, here's a model that I could create to help with productivity or efficiency or accuracy.
Yeah, I mean, anyone really, because like I said, like healthcare or finance, I mean, it's more like, oh, what if it's biased, or, I mean, let's say healthcare, it's my health. So, or a ton of people's health. So how can we trust this model to actually function the way a doctor can, or better?
Yeah, that's a big question. So I think the starting point that I would start is talk about like the accuracy of it, like where how have you developed the model, how is it accurate, and also the where does it fail, and where what kind of impacts could it have where it fails, and then because I think the kind of combination of inaccuracy with high social impact is that's the danger zone of we're just like we don't want to be in there in that space. So the more you can show people that it's accurate and it has low kind of social social inequity impact, then that's what you have to demonstrate. It's hard to do, but I think that both there's tools for like looking at your data to make sure your data is accurate and unbiased, and then also for testing it when it's done to check for bias and accuracy on the other end, on the output. There's some researchers working on the model explainability that could look into some of their work too. That they're working on things like feature importance of just like when you like which features on the input of your model are having the biggest effect on the output, and then you can use that to kind of tease apart to find if there's biases, because if there's a particular feature that seems to be connected to some bias and that has a huge importance in the model, then you can look at that as an area that you have to investigate more. So, and then of course, my bias into education, I think education is a really helpful thing to help companies understand how AI works so that they can have a good conversation with you about it. Like we do a lot of work with science centers and other places that I've given just a general AI literacy presentation to before we even start any work together so that they kind of understand the core things. So you could even start with that to just say, hey, let's just lay some groundwork on some AI literacy so that you can know how these models work, so that we can have a conversation about the accuracy and impact of them. I think that's another good starting point.
Yes, I was taking notes. Very. So okay, so you were talking about like I guess how to introduce certain things. So let's talk about accuracy, failure, the low social inequity, and so on. How would you? Because I love that visual that you showed. Really impactful, especially like it's a picture, so it's like who cares about the words? You just see the image, and it's like, oh, okay, I got it. Hey, look, that's our building. Or oh, look, I've seen that building before. It's like, oh, you can make connections like that. What would be, I mean, of course, it's depending on the type of AI and what you're doing. What would be, I guess, your number one go-to when you're trying to introduce data or in a model to, let's say, I guess, to a general public?
Can you make the example maybe more specific? You had some ideas before about like finance or medical or.
I guess let's go with, I guess, a medical, so it can feed on more on like, oh, hey, I don't trust it. How would you get them to trust it? What can you show? Maybe a video of it working and like live. I mean, what would be your medium to transfer that knowledge onto your audience?
Yeah, great idea. Okay, cool. And I think in medical AI, there is some danger around like the difference between kind of lab-based results that are just kind of like analysis of the data, and then there's the real world of just like how well it works in the real world versus on your test data. So I think in a medical situation, I think I'd really work hard to make sure that they know that this is validated by people too, so that it's not just a model that you've trained on data that you've got that's static, but you work with actual medical professionals in that field to validate its results. I think that would be an important one to show people how it's not only just accurate on the test data, but it's some doctors have said, yeah, actually that's a good result. And also look for what are the failure modes. So things like you could get, so for some detecting some rare cancer, for example, you could get that's a rare cancer. So you could have really high accuracy rates by just saying that the cancer is never there. Then we're 99.9% accurate because its chance of being there is really low. So explaining that kind of failure mode and how you've addressed that by just data augmentation techniques, or just the kinds of things that you have to do to make sure it's not failing in those ways. I would talk about those things too. And then what's your follow-up? What are you going to do to make sure that when it's deployed in the real world, that it's still ethical and accurate, to follow up over time with the model as well? Because there's a lot of models that have been deployed with good intentions and good lab results, and then they're just thrown out into the world. And then researchers have come back very much later, only when there was a problem that was being shown. So if you have some continuous monitoring and evaluation, then that I think would be good too.
Okay, thank you very much. That's very helpful. I don't know how much time we have left, but I do have one more question. I was a curious kid in school, and just that presentation that you were sharing, I kind of imagined myself sitting in like a high school class, and you would come in and present. And then, well, me being, obviously, I work with all this stuff, I would have been interested in it, right? And I would want to know more, because obviously I'm not going to have you for every day to talk to. It's not a class, it's just a presentation. So I want to know more. Is there any tools that you have, especially when it comes to younger audiences, like the one you showed us, but I guess a little bit more, where they can like not break it, but more as if they can build it on their own, and like maybe feed in actual like Excel files, like maybe a high schooler that knows about that, like they can feed it in. It's, it's not like TensorFlow or PyTorch or any of those where it's like you actually have to code more of, where you can just feed it in, and it's like easier for someone that's brand new to AI.
Yeah, such a good question. We always, on all the workshops, there's always a taking it further, and something that is like, hey, you like this? Go here, figure this out. And sometimes we'll even encourage people to be like, okay, if you got it already, here, go play with this code and do something on the side. This one we're not fully developed yet, but we're working on some. So Mo is actually working on some things where we can have participants put their own data in there. So in that model simulator stage, if you want to make that about something else, instead of it being about pies, you just have to feed in different data. And it actually is TensorFlow under the hood there. It's TensorFlow.js. So then we can actually make a data pipeline to get new data into there. So that's kind of the side project for that one. But then some of our other ones, like we have a chatbot activity where you make a mashup of different movie characters. You feed in, you make your own personal movie mashup chatbot based on your personal favorites of the movie characters. But we have we're using a database of, I think, about 10,000 movie characters. But what if the one you want isn't there? So great, it's open-ended. You can go and put your own lines in there. And then also Mo's worked on some code where you can connect that chatbot that you made, you can connect it up to Discord so that you can play with it with your friends in your Discord chat that you have with your friends. And it's not part of the workshop. It's just like, here's some code. You can extend what you did in class and have some more fun with it on the side. So I think you're absolutely right. That's really critical to keeping the people who are excited, keeping them engaged by giving them things to take it further.
Yes, I'm getting excited just imagining myself working with that. Thank you very much.
Awesome.
Thank you so much, Andy. We are over time. Can we take one more question if there is one?
I have time. If that's all right. Yeah.
Anyone? Jose, do you have a question? It's okay if you don't.
I just wanted to introduce myself. I'm Jose. a fellow for AI for Good Foundation, and I'm interested in green energy, and I just was checking your website that you have some work in that field. I would like you to expand a little bit more about it in the time that we're having right now.
Sure. Yeah, it's such a, thank you. I'll say that's such a important area. And so, yeah, we have one activity that's completed and published right now on it's the green energy forecast. So we have that one where we connect it to participants' lives in just the kind of their carbon footprint, and your energy usage has a big big impact on your carbon footprint. So that workshop is all about data analysis. So we have them think about some different kinds of data sources that they could use to kind of predict their electricity, energy, carbon footprint. And then we show them how the energy grid, it's made of different sources. There's wind, there's solar, and they go up and down throughout the day. So, but that's correlated to some data. When the wind speed goes up, then we're making more power from wind turbines. So we get them to look at different data sets, and we give them scatter plots and figure out which data is going to be good to train this model on. And then we train it, and they end up at the end of the workshop with a personal energy forecast, green energy forecast for their region, because they customize it for the energy mix of their region. And they have a little bar graph that shows throughout the day how much of their electricity is being generated by fossil fuels. And then they can use that in their life to make power decisions, like maybe don't put on the dryer at the time where the higher percentage is being made by fossil fuels. And we want to actually adapt and extend this workshop, because right now it's a bunch of it's in Python in a collab notebook, which is a bit inaccessible sometimes to people without the coding background. So we're looking at ways that we could maybe use our neural network simulator code to make that more kind of drag and drop. And so we're trying to figure that out right now. Yeah, that's going to be one of our next targets, because green energy, like that's climate change is the biggest issue affecting us as a species. So we want to have more of an impact in that area. So that's great to hear that you're working on that area, and there might be ways you could help us then in just how that's communicated and how that workshop works. I'm hoping that in general, this is the start of a conversation in both directions.
Well, thank you, Andy, so much for this really great, engaging workshop. And I love the discussion part of the seminars is one of my favorite things. You guys, as you know, Andy is part of our Council for Good. So if you'd like to follow up with him, obviously respect his time, but you can send him some follow-up emails if you'd like. So as part of the fellowship, all of our council members are here for you guys, and we're really excited about where your careers are going to go. So Andy, again, thank you so much. I'll be sending you a follow-up email, and Lindsay will be in touch about the video and everything like that. So everybody have a great rest of your Tuesday. Thank you.
Thanks, everyone.
Thank you.
Thank you.